So often when we're playing with probabilities, we're going to have data. So data and probabilities. We talked about way back in week 1 and week 2, these two-way tables where we have categorical variables involved. And categorical variables, for example, are like gender, right? Male or female. And even when we do age group, like people over 60, people under 60. So let's just look at a simple one here. Do male versus female. And then how about degree intent? And for degree intent, let's take a look at, say, nursing or other. And let's start with, make an easy number here, 100 people total. So we'll have some total columns going on too. So for totals, at college, many colleges now, there's slightly more females than males. So let's say we have a sample of 100 with 55 females and 45 males. As far as nursing goes, there's a lot of people going into nursing, so they take pre-nursing courses here, and then maybe they get into nursing program at BMCC, maybe they go to Walla Walla, Eastern Oregon. There's lots of options where people go to. So let's say maybe 10 out of every 100 students is going into nursing. So then we have versus 90 otherwise. And of these 10 here, there's way more female students in nursing than male. So let's say that's a ratio of 8 to 2 males to females. Okay, so right, 2 males plus 8 females is that 10 right there. Now, these two numbers are fixed based on the totals there. So I have 2 males accounted for out of 45 total, so there must be 43 over here. And then out of the 55, I've accounted for 8, so that's going to leave, what, 47? And just double check that this adds up right. 40 and 40 is 80, and 3 and 7 is 10, so there's my 90 there. And if I add up all 4 numbers here, I should get 100. So 45, and then 8 and 47 is 55. Yeah, those numbers work out. So there's lots of probabilities we can ask about this. Now, normal language, conversational language, isn't very precise about the way we say things, and we often, say something and somebody else doesn't quite get the meaning that we meant. So in probability, we try to be a little bit more precise about things. So I'm just going to put some things in words and then write down the probability language to go with it so I can be more exact about it. So for example, here I might want to know the probability, let's write in words first, probability that a student is male. So I might abbreviate that by saying probability male. And then look at this right here and say, well, okay, there are 45 males out of 100, so we could say 45 out of 100 as a fraction, or we could write it as a percent. So I'm just going to put 45 out of 100 for right now. How about the probability? Oops. That a student is male and in nursing program. Question number one, my question number two, so probability male and nursing. And I can look at the table and say, okay, let's see, we have 45 males, and then we have 10 students in nursing. 2 of those males are in nursing, so I think the answer here would be 2 out of 100, or 2%. Another one. Switch color here. Rate. Probability. A student is male or in the nursing program. All right, so I'm gonna let you guys think about that one for a moment before I try and answer it. Ability that a student is male or in the nursing program. I'm gonna rewrite that up here. Question number 3, probability male or nursing. All right, let me get my highlighter and kind of explain my thoughts. So I'm gonna go back to the previous one. What's the probability a student is male and in the nursing program? So I was thinking about all the male students here. And I was thinking about all the nursing students here. And that 2 where they overlap, right? Those are the ones that are male and nursing. Now, this is using a different word. Or means something totally different. So probability of male or nursing. So there I'm thinking, all right, what about male students? Well, there's 45 male students. So I think they're a possibility here. And then there's 10 nursing students. So maybe there's 55%. Problem with that approach right there is this 45 counts that too, and this 10 counts that too. So that's making me a little nervous. I'm gonna try again. Well, for sure I have 2 that are male and nursing. But these 43 here, they're male, right? It says or male or nursing, so 2 and those 43. Or nursing, there's these other 8 that are in nursing too, so shouldn't I count those? So that would be 8 there. All right, this one looks a little bit better. What does that add up to? 45 plus 8 is 53%. I get that right? I think so. If I had gone with my first take, I was saying that was 55%. Right? And I was thinking, I don't think that's right because that seems to double count the male nurses. Male and nursing. So this is an important idea in statistics and probability, the difference between or and when we're looking at some subgroup of a population. This is called the addition rule in statistics. And it gets back to my concern about the double counting back here, that if I just grabbed this total here and that total here, it accidentally double counts those 2 there. And so I can write that out using some of the notation I've been using here. And instead of, I'll write it down with the male and nursing, and then we'll write it down more generally. So I was trying to find what is the probability of someone being male or someone being in the nursing program. So I need to consider all the males, I need to consider all the people in the nursing program. But there are people that are male and in nursing. So if I just find all of the people that are male, and separately I find all the people who are nursing, those double count the people who are both. So I have to subtract the probability that someone's male and in nursing. So usually that's rewritten, you have some event A or some other event B. So or ends up being an addition. So probability of A plus the probability of B minus any overlap they might have, A and B. I'm just going to demonstrate this in a couple of different ways. I mentioned Venn diagrams earlier. So if I put this Venn diagram, we start with some box, and then the groups I'm interested in the males, and I'm interested in the people that are in nursing. And there were two people that were male and in nursing. Right? I look back at the table here. There were 43 other males for the total of 45 males in the blue circle here. And there in nursing, there were 8 other females. So there's the 10 total. And so we just have to be careful not to double count, and that's what this subtraction is about there. So just something to keep in mind. Other interesting graphics, I think, in talking about this is the idea of those two-way tables we were just looking at. And highlighter. The idea of there being possible overlap. And so the idea, the probability of A or B is here anything that's shaded. All right, so I added up this box, and that box to figure out the A or B. In the two-way table. Just a different visualization there. Oops, sorry. I wanted to match the other. And then when I'm looking at the probability of A and B, that's just the overlap in shading. If I have a two-way table or some kind of table of data, so just that number right there is the one I need to find my numerator for the problem. Again, this is called the addition rule.